Now let's take a look at what happens when we multiply or divide with exponent or with scientific notation. So in the first example, we have 2 times 10 squared times 3 times 10 to the 4th. So note what the 2 and 3 we're supposed to do is to multiply the 2 and the 3. And then note that we will add the exponents because we have the same base of 10. Therefore, 2 times 10 squared times 3 times 10 to the 4th is 2 times 3, which is 6, and times 10, 2 plus 4 is 6. So we get 6 times 10 to the 6th. Let's take a look at the second example. We get 6 times 10 to the 5th times 5 times 10 to the 7th. So once again, we know we're going to multiply our two coefficients, I guess, which is 6 and 5, which gives us 30, times 10, and we add our exponents, 5 plus 7, which is 12. Now, down here, there's an asterisk, and it says you got to change this one to scientific notation, meaning we need to take our decimal point and move it one more space. The reason we need to change this is because 30 is not between 1 and 10. 30 is more than 10, therefore 30 times 10 to the 12th is not scientific notation. If we move it one more to the left, we get 3.0, or just 3. And since we moved it one more to the left, we've added 1 to our exponent on 10. So we get 3.0 times 10 to the 13th, or 3 times 10 to the 13th. However you want to look at it. But it's important to note that if your answer is not in scientific notation, you've got to go ahead and change it into scientific notation if you are asked. Now let's take a look at number 3. 7.7 times 10 to the 3rd times 8.4 times 10 to the 4th. So once again, we know we've got to multiply 7.7 times 8.4, which is going to give us 64.68. And we know we're going to add 3 plus 4, which is going to give us 10 to the 7th. But we know that 64.68 is not written in scientific notation. So we have to move the decimal point one more space to the left, meaning we're going to add one more to the 7th. So we get 6.468 times 10 to the 8th. We had to move it again because 64.68 is not between 1 and 0. We need to make sure that our starting number is between 1 and 0. Now taking a look at number 4. 4.8 times 10 to the negative 5th times 5.5 times 10 to the negative 6th. Even though they're negative exponents, we're still going to go about it the same way. 4.8 times 5.5 equals 26.4. And 10 to the negative 5th plus negative 6th is going to equal 10 to the negative 11th. 26.4 is not in scientific notation, so we need to move it once to the left to get it as 2.64. And then we need to add one more to our exponent, giving us times 10 to the negative 10th. Now let's take a look at what happens with division. So looking at example 1, we note that we have 2 times 10 to the 4th divided by 5 times 10 squared. So note what we're doing is we're dividing 2 and 5. So the operation in between the two scientific notations is what we do the constants. And then because we're dividing, we'll subtract the exponents. Well, 2 divided by 5 happens to be 0.4 times 10 squared, because 4 minus 2 is 10. That is not scientific notation, and again, I gave you that little note about that. So we have to make it scientific notation. We move it 1 to the right, meaning we're going to subtract 1 because we moved to the right, giving us 4 times 10 to the 1st. So to review, when we divided the constants of 2 and 5, we got 0.4. 0.4 is not between 1 and 10. Therefore, we had to move the decimal point 1 to the right to make it 4, which is between 1 and 10. Because we moved the decimal point 1 to the right, we had to take away 1 from our exponent on 10. We got the 2 by saying 4 minus 2, and that's how we get 10 to the first. Let's take a look at number 2. It's still a division problem. This time it's written as a fraction, but it's still the same thing. We have 7 divided by 4. 7 times 10 to the 9th over 4 times 10 to the 3rd. So we know we're going to divide our constants of 7 divided by 4, which is 1.75, times 10 to the 6th, because 9 minus 3 is 6. For these divisions and even on the multiplications, please utilize your calculators. Unless you are dying to divide this by hand, I am not expecting you to divide, nor am I expecting you to do that difficult multiplication, or I shouldn't say difficult, but more complicated multiplication with these. Feel free to utilize the calculator for that. Now taking a look at example 3. We're asked first to do 6 divided by 3, because, the problem says 6 times 10 to the 7th divided by 3 times 10 to the 9th. So we divide 6 divided by 3, and we get 2. And then we're going to subtract 7 minus 9, and that's going to give us 10 to the negative 2. So our answer is 2 times 10 to the negative 2. Now moving on to example 4. We have 4.0 times 10 to the negative 6 over 8.0 times 10 to the negative 3. So we're dividing 4.0 divided by 8.0, which is going to give us 0.5. And then we have 10 to the negative 6th minus negative 3, which is going to give us 10 to the negative 3. 0.5 is not scientific notation because it is not between 1 and 10. We have to move the decimal point 1 to the right. Therefore, we're going to subtract 1 from our exponent on 10. We end up with 5 times 10 to the negative 4th. So the hope is that you have noted that if the decimal moves left, you'll add 1, or you'll just add, and if the decimal moves right, you'll subtract. Now for the last page, we're asked how do, pretend that says do and not do, how do the numbers compare to one another? Well, we should note that 4.5 times 10 to the 6th. We note that that's 4, we move the decimal point 6 spaces. One, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So we get 4,500,000. And then for 9 to the 6th, 1, 2, 3, 4, 5, 6, we're going to add 6 zeros. Which is 9 million. And then for 4.5 times 10 to the 7th, 1, 2, 3, 4, 5, 6, 7. And we get $45 million. So how do these compare? Well, we should note that A is half of b that c is 10 times a. You could also say that b is 2 times a, or or a is 1/10 c. And notice that that's all dealing with just the exponents. So if you take a look at a and b had the same exponent, but 4.5 is half of 9, so therefore, or 9 is 2 times 4.5. So it would make sense that even though they have the same exponent, that there's these super huge numbers, their relationship's still going to be the same, whether they're just 4.5 and 9 or whether they're 4.5 million and 9 million. Regarding a and c, by adding one more to the exponent, that's all we did, we have made it 10 times bigger. We've moved the decimal point one more. We've multiplied it by 10. And that's why c is so much larger. And then there's not really a direct correlation between b and c other than it's going to be 5 times the amount. But that's a lot harder to see regarding the 4.5 being half of 9, but it having one more exponent. So we're not going to pay too much attention to how those two compare. And that is it for exponents and scientific notation.